Well, thank you for coming to the last talk of the show. I'm Matthew Phillips from Sine Nomine Software. Most of the stuff I'm showing, I think, was probably written by Hilary, who is on the stand out there. Can I just have a quick show of hands for who hasn't used our RISC OSM map software? Okay, about 4, okay. And is there anyone here who... well, actually, we'll leave it at that, because that's probably mainly what I'm talking about. RISC OSM, briefly, is mapping software for RISC OS. We use open, free data from OpenStreetMap, which is kind of the Wikipedia of maps. Anyone can go on there and contribute footpaths, points of interest like post boxes, recycling bins, all sorts of things that you need in the detail on maps can be added by anyone around the world with a simple account. We take that data, process it to make it easily retrievable from disk, and you load the data off your disk, and it renders a map as a draw file. And of course, we all know the advantages of the vector format and draw files. You can have high definition zoom in and everything like that. So that's what RISC OSM is all about. Now, one of the big challenges that you have with map data is it covers potentially the whole world. And this is where RISC OS has been very bound in the past to a Western European and very much on the whole a British perspective, where most of the time we don't worry about anything that's not in the Roman alphabet. We don't even worry about accents on letters very much. We worry about it so little that when the ISO Latin 1 character set for Western Europe was created, the story is that no one from the British delegation happened to mention that we might need W circumflexes and Y circumflexes to support languages in just to the west of England. But, you know, we don't worry about that kind of thing, most of us. So Acon, to be fair, did actually worry about that. And the Acon Latin 1 character set includes the accents that you need for Welsh. Anyhow, when we started developing RISC OSM, we first of all launched data for the British Isles. But of course, we then got requests for, well, what about other countries? So over time, we've supported more and more of the world. But we are still very much limited by the font support in RISC OS. So I'm just going to go and, well, demonstrate that we have in our place name gazetteer, you can go and search for Athens and draw a map of Athens. But up until the release that we made at the London show, you couldn't search for Athens in Greek because all we were allowing you to type in there was letters off your keyboard in Latin 1. Now, for Athens, that's not really a problem because OpenStreetMap has Athens as a name alongside the Greek names. You know, there's all sorts of different alternative names for most places in all sorts of different languages, and they're all in there in the OpenStreetMap data, so we can index it. But smaller places in Greece, that might not have been transliterated. And also, anyone who is a Greek user of RISC OS might well prefer to be able to type in Greek. So we are now supporting being able to type in your search in other character sets as well. So if we do start doing this, oops, I think I've got the wrong E. There are 2 E's in Greek. There we are. So as you can see, we've now got Athena. I don't know, I can't pronounce Greek. I can only do maths with it. But here is Athens. And you will see that we have this wonderful bit of Greek actually in the icon and we can edit it, so I can type. And if I'm using this nice little tool here from Paul Spranger's, which allows us to type in any characters we want. Now, there's a lot of very peculiar things going on behind the scenes with this. For one thing, you might be wondering, well, what's going on there? We're typing a load of non-Roman characters into this icon. Well, that icon is not a RISC OS icon. That's not a standard icon. It is a box that looks just like a RISC OS icon, and there's a white space in there. There is the icon standard caret, that is the real, genuine caret, but those characters there are not being rendered by the WIMP. They are being rendered by the font manager at our instruction into the space in the window that where the characters are needed, and the caret is being positioned in the right place so that when we get that key press to move right or left, we are calculating where that needs to be. The font manager helps with that, and we are moving the caret. So the WIMP is not doing any of that. Normally, with a writable icon, the WIMP is doing all of that work. So yes, the WIMP can do that. You can change your computer to use the UTF-8 alphabet, and then the WIMP will, to some extent, support typing in all sorts of exotic characters into icons. But you will then find that various other applications which aren't expecting that will do very strange things. So until we have much wider support for Unicode in RISC OS applications, most people are best off sticking to using the 8-bit Latin 1 character set. So how do we actually know that we're meant to be typing in UTF-8? Well, that's where we can benefit from the fact that Unicode has an immense amount of structure. UTF-8 has an immense amount of structure. So you can have characters, or Unicodes to be more proper about it, can be anything from 1 to 4 bytes long. If they are 1 byte long, then the top bit is 0. It's equivalent to ASCII. In fact, it's identical to ASCII. If you need higher bytes, higher code points within the Unicode structure, you need more bytes. If you have multi-byte ones, then the first byte indicates how many bytes will follow. So you'll see here, this second line, you've got the top 2 bits are set, and that means that there are a total of 2 bytes in the encoding altogether. The third line down, where there are 3 bytes, the top 3 bits are set in the first one. All the following bytes just have the top bit set and the next bit as 0. You see, it's the position of the 0 after the 1s, which helps indicate where all these how these bytes are to be interpreted. So there are some real advantages to this format. One is that you can dive into the middle of a UTF-8 encoded file, you hit a byte, and if it starts 10 at the top, then you know you're in the middle of a multi-byte character. You can either backtrack to find the start of the multi-byte character, or you can skip over to find the beginning of the next one, but you always know where you are. You don't have to read from the very start of the file to be able to synchronize your decoding of this stuff. So it's a really neat format, has lots of advantages. But you see, those advantages mean that it isn't actually the most compact way of encoding that information. They could have made it much more compactly encoded if it didn't have that structure. But that structure helps us in editing files, it helps us in navigating those files, but also that structure means that there is an inherent way of recognizing when you've got UTF-8 encoded text. It's not totally perfect, and if you talk to Nemo around the corner, he will tell you why you cannot really do this, but we are doing this. We are looking at the text and making an informed judgment as to whether it is likely to be UTF-8 encoded or not. And over 99% of the time that will be right, and that's better than doing nothing at all by a long way. So I haven't actually demonstrated drawing the map. Let's just draw the map, and you'll prove that you will get Athens appearing on screen. And some of the labels on this map will be in Greek, and some of them, well, in fact, they're all looking like they're in Greek. That's probably because I haven't actually chosen the settings in. So if in RISC OSM, you can choose what your preferred language is. So if I prefer to read things in English, I can do that. It'll re-render the map. And where there was an English transliteration, you see we got plenty of things saying Athens here, and Tavros, and Kalatea, and so on. But we've also got the Greek appearing where there hasn't been any transliteration put in place. And these changes back in, I mean, we've been rendering maps with exotic characters in like this for quite a while, but the big change that came in October was allowing people to type and receiving text into all of the different fields. And if you were wanting to, say, add this to the bookmarks, we could, if we wanted to, type in Greek in here as well. I'll just type some random things because that's going to be quicker for the demo. But you can see there that we've got that in the bookmarks. And when I open it, there will appear, perhaps I failed to save. Anyway, it would appear in there. So by doing this work for improving RISC OSM was what got us into the whole Unicode support needs. We've been able to take advantage of that in other applications. So imp email is another one, and imp email uses exactly the same trick, kind of looks like the WIMP icon but isn't, kind of stuff. So the same code is used there, and we can type all sorts of different characters into imp email. Now, imp email is one of our more esoteric applications, but it is quite a useful piece of kit. It allows you to send bulk messages to a set of people. That could be your Christmas letter. It could be something for a club or whatever that you're running, all sorts of different purposes. And it's designed to be used with impact, that's why it's called imp email, but it also can be used totally standalone using CSV files. So I'm just going to demonstrate with this. We've got here a CSV file full of what looks like mainly gobbledygook, because ZAP does not support UTF-8. We are seeing here what ZAP thinks is a load of bytes, but actually these are UTF-8 encoded strings of various sorts, some more complex than others. But we can now drop that onto imp email as the input for the different mail merge fields within the message. And you'll see here, the first one here is in Greek. The second one is largely Roman characters, but there are some Latin 2 characters to support Polish in there. The third one is Cyrillic, and then this one here, Czech. So again, Latin 2 characters, I suspect. I can then test any of these in the email message. There we are, test. Oh, whoops, I need to go and run a printer driver. Wait a minute, there we are. Here is the email that would be sent. And it's saying, we'll be sending the magazines to your current address, which we have recorded as that. Please let me know of any corrections, etc., etc. So this is also demonstrating the fact that you can have an attachment, either Ovation Pro or messenger documents can be attached to imp email, and they can be mail merged as well, so that the contents will then be turned into a PDF, which will be attached to the email. So it's quite a nifty piece of thing that's it's very good for generating invoices, for example. Now, here you see the problem that, of course, we don't have Unicode support in Ovation Pro, so you just get a lot of question marks. I'll just clear that one out. That shows you the merge commands. Obviously, with the Polish one, if we test that, it does a much better job, and it is sending through the imp email will send through the contents to Ovation Pro with the letters having the accents removed where possible. So there was a Z grave and an N acute in that person's name. Those have been stripped out because they're not supported in Latin 1, but it does mean that we get a reasonably decent outcome in Ovation Pro for this one, but it's clearly not usable for Greek or Cyrillic at present. So that's the improvements in imp email. Now, for this show, we've done some nice work with Impact for our, where are we? So 2 or 3 years ago, I think, we introduced some features in Impact to allow you to import files as the source for a database. So if I just demonstrate that quickly, we might have, say, a load of photos. If we go to the import tool for Impact to create a brand new database, we can drop a selection of files onto the CSV import tool. We need to change the icon, really, because it does now support arbitrary files. You can scan the files for additional information, and it will then give you an import window where it is offering the file name, the file type, the file size, and the date. Those are all things that you can easily get from the filer, and this could be the basis for a database of your photographs. But for JPEGs, it will also read extra information from the files, such as the width, the height, the image date, latitude and longitude, if those are encoded in the file. So we've used this to demonstrate a photo database. And here we have an example photo database, and you could import things in bulk into this, or you can start with an individual file and drop it on. And when you drop that on, an action script runs, which goes and gets various bits of information from the photograph. But the new feature for this show, I don't know whether you noticed that location bit at the bottom popped up slightly later than everything else. That's because in the background, after the latitude and longitude have been loaded, it goes off and talks to the Nominatum application, which is what RISC OSM uses for finding locations of places around the world, for doing searches by place name. And it does a reverse lookup from the latitude and longitude to get a description of this place from Nominatum, which is then putting into the location field in the database. So we've now got a function in Impact's scripting language, which allows you to take the coordinates of a place somewhere on the Earth, and it will attempt to get a description of that back. You'll probably want to edit it, and it sometimes gives some very wacky results, but it can be a bit of a time saver. So, and also, I should just demonstrate as well that if you've got an individual photo and you're wanting to upgrade a record, you can click on the Set Location button. Instead of typing a new location in or dragging this to drop on a RISC OSM map, you can just click Select, and it will look up that latitude and longitude. Sorry, not click on Select. You click on the little icon there, and then it looks up and obtains that description again. And it's all very well integrated with RISC OSM, so if you decide that actually this photo was taken in the middle of Athens, you can go and drop that little pin somewhere there, and it will then get the description back in here, and you can then send it through. Now, if I do that, you'll immediately see that although the latitude and longitude have changed, that location is a load of question marks, and that's because impact doesn't yet support UTF-8. So it's a steady bit of work to improve applications, and if we're going to support wider sets of characters for international use, there's going to have to be a lot of work by developers to get this right. And I was going to demonstrate something with a... No, yeah, so I haven't found the example actually beforehand, which is a bit of a shame. But sometimes you get information in JPEGs as well, which you can read in, and they will appear in the caption fields automatically. I don't know actually whether the standard for a JPEG is to encode things in Latin 1 or in UTF-8. But the problem is that there is a mixture of stuff out there, because it's absolutely certain that some RISC OS applications which allow you to edit captions for JPEGs, things like variations, for example, they are using Latin 1. Whereas there's definitely photos out there you can download from the internet which are using UTF-8. So again, we are using these methods of trying to guess what character set it is in order to give the user the best experience. So that's why we need to do those sort of pragmatic approaches. And while we're here, just a little reminder that impact can integrate with RISC OSM the other way round. If we want to search for photographs in impact from RISC OSM, we can do that. I think I'd better go to Durham in UK, first of all, and I've got the Greek keyboard on, so that didn't really work very well. Let's try again. So and I need to choose the British Isles for my data set. So if I go through to Durham and ask RISC OSM, so RISC OSM can then ask the impact photo database for any photos within the map area and fetch them. It will then display pins on the map and thumbnails over on the right-hand side, which is very neat. So in RISC OSM, we have some little enhancements as well. One of those is to the pins and tracks window. And I think I'll just demonstrate fetching a few more pictures from the web. So I'm going to get some photos from Geograph, and we'll get some more in. So the pins and tracks window displays all the details of stuff which is being overlaid on the map. And up until the release yesterday, RISC OSM showed any descriptions just strung out on a single line which stretched from here over to beyond the right-hand edge of the screen, and you'd have to scroll your window sideways. But as you'll see now, we've dispensed with the horizontal scroll bar, and you can now resize your window sideways, and it'll word wrap everything and move everything up and down. So very simple improvement in terms of the concept. Probably took about a month of work. And this is a free upgrade if you upgraded in London. We're not charging any extra for that, though. It sort of felt like it really ought to do this. So despite it being a massive amount of work, there you are. It seems to be working very nicely anyway. Anyhow, the other thing that we've been up to, which has been quite fun, is a whole new application. And to demonstrate this, I'm going to, first of all, quickly get rid of all of those pins and enlarge the map a little bit. And let's go to Warrington. And if we go a little bit over from Warrington, well, hang on, I'll just find the other bits of software. So the last 2 or 3 years, we've been developing a few example little applications in Python. Obviously, in the RISC OS world, there's a lot of people writing in BASIC. There are people writing in C. C is notoriously tricky to get right. There's lots of ways you can make a whole mess of the machine with C. And it's very powerful, but there's a bit of a steep learning curve there. BASIC is very powerful in its own way, and lots of people like it, but it has all sorts of things that are difficult to do in terms of a modern programming environment. No support for long strings, objects and structures that are part of the modern programming experience are really absent from BASIC. So Python is a really good alternative, and there are lots and lots of tutorials out there on how to write Python in general. Python for RISC OS is pretty well supported, and Chris Johns has written an excellent toolbox library for Python, which allows you to use the RISC OS toolbox from Python in a very friendly manner. So we've been writing a few Python applications just to demonstrate how this can be done, and they're all available from our website. You can download and explore them. They've got lots of comments in hope that it will help people see how things can be written, because it's often easier just to take another application and grab bits from it and rework it to what you need to do. So the latest of these is a little application called PlaneSpot. And with PlaneSpot, we are demonstrating not just how to write an application in Python, but also how to get it to talk to RISC OSM. So there is an API out there called Open Sky Network, which has been set up for academic study of plane movements, and you can get a free API key from it in order to be able to read plane locations and other data. So we will go and fetch information on aeroplanes that are currently in the area. Here is Manchester Airport, and there are a number of aeroplanes around. This display will update every 30 seconds and move the aeroplanes across the map. We can also control-click on any of these pins and open a plane information window, which gives you a bit more information about what these aeroplanes are. It varies according to how much information the APIs have. So you'll see here we've got one which has a photograph, a couple which have photographs, and they sometimes have destinations and airlines and everything. And where there is extra information available, like an official website for the airline or a Wikipedia entry, you can go and click and open up the Wikipedia page for the airline, or indeed the original destination airport. Now, big caveat here, we are just displaying what the APIs tell us, but it's clear that from inspecting what we're being given, that some of it is wildly out. The aeroplane that we witnessed over Lincolnshire this morning, which said it was on its way from Amsterdam to somewhere in the Far East, I don't think was going via Lincoln. The data must have been incorrect. But we're displaying what we can get here. And again, this is another example of where we have needed to be pragmatic about what we get back from an API, because you see here that it says Tromsø Airport in Norway. Well, that O with the line through, I don't know the official name there, that will have been given to us in UTF-8 rather than Latin 1, because most of the APIs out there on the web will be using Unicode these days. So it should have been given to us in UTF-8, and we are displaying that through the font manager by stipulating that the encoding of the string that we're rendering is UTF-8. Job done, that should be no problem. Except, sometimes we find that what they've given us has been encoded in UTF-8, and then the whole string has been re-encoded as though it had been an 8-bit font, and it's re-encoded again. So that means you then get sort of double characters for the for the more exotic ones with accents, and they all start looking very odd. So in the Python code, we have put in place a little bit which attempts to decode from UTF-8, and if that succeeds, it attempts to decode from UTF-8 again, just in case it's been double encoded. And that way we can display something that looks right, even though the API and the data out there might be giving us the wrong thing. So even with a modern API where it tells you that it's giving you UTF-8, you sometimes still need to be circumspect and apply a bit of intelligence to enable the user to have the right experience. So we've done the control click on the details of planes. You can, if you want to, follow any of these planes. Map follows point, and as that plane moves, the map will then move across the screen. And we also have the option now, this is a new choice for data streams, we can orient the map so that the point always travels up, which means the land that you're looking at is set out before you as though you're about to fly over it. I'm just going to set to a different map style here so that you can see what it does. So I think, if I've got this right, the next time that plane moves, just make sure I've got the right one. Yes, the next time this plane moves, I think we should then find the whole map reorients so we're seeing the ground underneath ahead of us. Yeah, there we go. And it should then gradually proceed across the map, and when it nears the top, the map will re-render with the plane at the bottom. This is where we see it's quite slow loading 13 megabytes of data, but here we are. We're looking west, and this aeroplane is an Airbus on its way to Gran Canaria, it says. Not sure whether that's really in that direction, but anyway, maybe it's going to turn a bit, or maybe the description's wrong. Good. So, do we have any questions at this point? I think we're kind of getting near the end of the allotted slot.
Is it only civil aircraft?
I think it is only civil aircraft.
If you went to something like Fairford, if you went to Fairford, for RIAT, would you get information of the military aircraft that are displaying?
I suspect not, but you just have to try. I've no idea.
Thank you.
Any other questions? Well, as I've gone on for half an hour, I'd probably better stop. I had been vaguely intending to show you how easy it was to alter a Python application by doing a bit of live coding and adding a further choice to PlaneSpot to set the frequency of the updates, which only took me about 3 minutes to do this morning, but I suspect in the pressure of standing up and typing, I would make too many typos. But if anyone wants to see that, then put your hands up and I'll carry on. Otherwise, there's one taker, but I think I might spare you, or spare myself the embarrassment of being on video making a complete hash of it. So thank you very much.